What's going on, y'all? Sean of MathSwap Tutoring here, and in this video, we are going to talk about geometric sequences, and specifically, we're going to talk about um, how to find explicit and recursive formulas, which will help you to determine terms in the sequence. Okay, it's all going to make sense at the end of this video. Make sure you like and subscribe so that you get updates whenever we put out new videos. All right, so let's get into a couple of definitions here, first of all. So, first of all, a sequence is basically a list of numbers that has a pattern. This is important to note. Pattern. This is important to note because there are a couple of different kinds of sequences. Oops, I skipped one there. Okay, so there's one sequence. Um, there's another one. Okay, now this first sequence here is what you would refer to as an arithmetic sequence. We're not talking about those here. I've recorded another video where I talk about that. However, this is a sequence because you see a pattern of adding 2 between each terms. 3 plus 2 is 5, 5 plus 2 is 7, 7 plus 2 is 9, 9 plus 2 is 11, and so on and so forth. What makes it arithmetic is the fact that you're adding or subtracting between terms. And that number that you're adding to, that's what you refer to as a common difference. Now, here, if you notice, to get from 2 to -4, we're multiplying by a -2. To get from -4 to 8, we're multiplying again by -2, and so on and so forth. This is a geometric sequence here. So what I'm going to do is I'm going to erase that, and then I'm going to, oops, I'm messing up my notes and everything. Okay, let's put our P back. Okay, now this is a geometric sequence, and a geometric sequence is a list of numbers or a sequence of numbers in which um, every two terms has a common ratio. I don't like my definition too much there, but it's okay. And we usually denote common ratio as R. So what I mean is it's a common ratio that allows you to get from one term to the next. So 2 to get from 2 to -4, we multiply by -2. And it's the same to get from -4 to 8, you multiply by -2, and so on and so forth. That is what's called your common ratio. Now, from there, let's go ahead and talk about a recursive formula. Well, actually, we don't want to talk about recursive formula yet. We want to talk about the difference between explicit, sorry, Nat in here, explicit and recursive formulas to find um, terms in a geometric sequence. So the first thing I want to note is going to recursive. The word recursive means something that is repetitive, something that is repeating. Okay. And so whenever we use a recursive formula to find terms in a sequence, you have to know the previous term to find the next term. Okay, so what do I mean by that? What I mean is you have to have the term before, say for example, you want to know term number 3, the third term. You have to know term number 2 to find term number 3. And for term number 2, you had to have known term number 1 to find that one. To know term 47, you have to have known term 46. And so what happens is it's a formula that you have to use multiple times, okay, to find whatever term that you're looking for, okay? Now, explicit, this allows you to directly find the term you're looking for, no matter where it is. Sorry, I'm writing kind of fast. So basically, it don't matter if you're looking for term 3, term 47, term 1186. This will allow you to directly plug in, I want that number term, and then you get whatever that value of that term is, okay? So explicit formulas actually seem to be a bit more useful because you don't have to like use them so much, but we're going to talk about both here. All right, so what we're going to do is I'm just going to do this one example of that we have here, the 2, -4, 8, -16, and so on. So let's hopefully you've taken these other notes. Let's get rid of this stuff here to get our space back. Make sure you take notes. Make sure you watch the video as much as you need to make this make sense. And I'm also going to do this. I'm going to put um, isolate this data by circling it. All right. Now, let us first find a recursive formula for um, finding geometric terms in a geometric sequence. Okay, so first of all, the first term which we're gonna how do I want to say this? So if a of n, so it's a function. If a of n represents a function that we use to find the nth term of a sequence, so you know a of n is a function for um, finding terms in a sequence. N is the number of the term. So the first term, the second term, the third term. So if A of n is kind of like our what we use to denote this function, then define so this is the information that you need for the recursive formula. So A of 1, that's going to be your first term, okay? That represents your first term. And so we're going to denote that by the letter K. Okay, that's going to denote your first term. Okay, and then the full formula recursive. So this is recursive, and I actually I do like I'll do something here in a second. So the full formula to find a term in a geometric sequence, the recursive formula today is the following: a n minus 1 times r. Okay, so that this is our recursive formula. Okay, so what is it that makes this recursive? So what happens is we know that R, I need to rewrite that. That's our common ratio. What happens is if you notice here, to find a term, you have to multiply the term before it, okay, which is n minus 1. So if you're talking about the second term, that's a of 1. I mean, that's a of 2. The term before it is a of 2 minus 1, which is a of 1, times the common ratio. So you see, there's the recursiveness in it. Now, you have to know the first term because you have to know where it starts since you have to use it until you um, find the term you want. So if we want, in this case, if we know the first term, if we know the first term is 2, and we know that the common ratio is negative 2, then when we plug this in, so a of 2, in other words, our second term, is equal to a of n minus 1, which in this case is a of 1, times negative 2. Or in other words, what was a of 1? That ends up being your first term, which is um, 2 times negative 2, which is negative 4, right? Good. And then if we wanted to find, sorry, it's a net in here still. If we want to find a of 3, that's equal to a of 2 times negative 2. Or, in other words, that's negative 4 times negative 2, which is positive 8. Okay? So, yeah. So, you see how it's recursive in that you have to keep on using it to get to whatever term you want. Now, let's erase this stuff here. Hopefully, you took notes. If you didn't, you can always rewind the video. And let's talk about, sorry, let's talk about explicit. Let's talk about explicit formula. Okay, using the same set of data. All right, so the explicit formula is as follows. A of n equals k, and I'll write here k first term, or like we said, that's a of 1. Because k times r to the n minus 1. Okay, so what does that mean? This is explicit. So how is this explicit? So this allows you to directly find the term you're looking for. So it's the first term times the common ratio, which is raised to the n minus 1 power. So how does that work? That means that if you're trying to find term number 4, you're going to multiply the first term times the common ratio 3 times. Okay? So it allows you to directly, since you're raising that common ratio to a power, to the power n minus 1, it allows you to multiply the first term by the common ratio enough times to get to the term you want. So see how quick it is. It's actually pretty cool. So let's use the explicit formula to find term number 4. So A4 would be equal to K, which is 2, times R to the n minus 1, or 4 minus 1, which is 3. Let me, instead of R, we already know what that is. That's negative 2. Okay? Or in other words, that's 2 times, what is negative 2 to the third power? That's negative 2 times negative 2, which is 4, times negative 2 is negative 8, equals negative 16. You see? Bingo. So you're able to go right to the term that you want. Okay? So that's a quick and hopefully helpful tutorial over geometric sequences and the explicit and recursive formulas for finding those. Let me know in the comments if this video was helpful, and have a good one. Hey, thank you for watching this video. If you need math tutoring or you need SAT math help, look in the description to find out how you can sign up today. Also, don't forget to like, share, and subscribe so you stay in touch with Math Swap Tutoring on YouTube. Have a good one.